This video will cover part of electrochemistry called oxidation number. In it, we will talk about how to determine the oxidation numbers for individual atoms and atoms within larger molecules. So the oxidation number itself refers to the number of electrons that an atom has in a molecule compared to its elemental form, based on the comparison of electronegativity of atoms that share a bond. Unlike when we were talking about formal charge in context of Lewis dot structures, in formal charge the atoms were equally split amongst the bond. In the case of oxidation number, when you have two atoms bound together, the more electronegative atom that shares the bond gets assigned all of the electrons. So the way this works out is, in terms of general rules, atoms that are all by themselves in their elemental form, be it like neon or O2, are going to have a 0 oxidation number. Monatomic ions are the same oxidation number as their charge. So chloride ion, Cl- would be a -1, a sodium ion, and a plus would be a +1. Oxygen is going to generally be -2 unless it's bound to itself, in which case it will be a -1 if it's bound once to an oxygen, or 0 if it is bound twice to an oxygen. The reason for this is when we're looking at electronegativities, oxygen is the second most electronegative atom there is, meaning that if anything is bound to it other than fluorine, the oxygen will be the more electronegative of the two, and it will get assigned all the electrons. And oxygen typically forms two bonds, and so it will generally have a -2 charge. Hydrogen is going to be +1 unless it is bound to a metal. In that case, it will be a -1. The reason for this is hydrogen has a fairly low electronegativity. It's on the lowest end of the nonmetals, but metals themselves have yet lower electronegativities. So metals are less electronegative than hydrogen, and hydrogen is less electronegative than most of the non-metals. Right? So most of the time, if hydrogen is bound to something that's not a metal, it's going to be a +1. If it is bound to a metal, then it will be a -1. Halides, like fluorine, chlorine, bromine, and iodine, are going to be -1 unless they are bound to oxygen, fluorine being the exception. Fluorine is the most electronegative, so it will always be -1 unless it's bound to itself. Chlorine, bromine, and iodine are less electronegative than oxygen. So if oxygen is bound to them, then oxygen gets assigned the electrons. In all other cases, if you have a halide that's bound to something that's not oxygen, the halide is generally going to be the thing that's the most electronegative and will so get assigned those charges. Now the sum of all of your oxidation numbers in a molecule must equal the charge of the molecule. This is a way of counting electrons, so your total number of electrons have to work out to be what the total number of electrons are. So looking at some examples, going back to our general rules, halides are going to be -1 unless they're bound to oxygen. So our first example, sodium chloride, NaCl, the chloride is a halide, and so it will get a -1. Now I'm going to write the oxidation numbers above the atoms, and I'm going to enclose them in a set of parentheses to denote that that is the oxidation number of those atoms, not the sum of all the atoms. So the chloride, each chloride ion in the sodium chloride is going to have a -1 oxidation number. The sodium atoms are going to be +1. Right? Sodium is a lot less electronegative than chlorine. They share one bond, and so the sodium will be a +1, the chloride will be a -1. For magnesium fluoride, each fluorine is a halide, and so they will be each -1. The magnesium, right? The charge on the magnesium, you have 1 times whatever the charge on the magnesium is, plus 2 times the charge on the fluorine, and that has to sum up to be the overall charge. So 1 times n plus 2 times -1 equals 0, and so n would have to be a +2. For copper 2 chloride, the chlorides are all halides, and so they will be -1. They're not bound to oxygen. Each one is a -1. The copper needs to balance that out. You have essentially two -1s. The copper needs to balance that out, and so it will be just like the magnesium was, a +2. Silver bromide, the bromine is a halide, and so it will be -1. To balance out the charge, the overall charge is 0, so the silver has to be +1. Magnesium oxide, the oxygen is not bound to any other oxygen, so it will be a -2. The magnesium has to add up, the oxidation number on the magnesium has to add up with the -2 to get your overall charge, which is 0, and so the magnesium has to be +2. Copper oxide, or copper 2 oxide, the oxygen is going to be a -2. The copper, to balance out the charge, or to balance out the oxidation number, should be +2. Copper 1 oxide, the oxygens are each, well, there's one of them, it's going to be a -2. The number on the copper has to balance out to give you 0 overall charge when you're adding it to the -2. So 2 times whatever the number on the copper is, whatever the oxidation number is, plus 1 oxygen times the -2, the oxidation number on it, has to equal your overall charge, which is 0. So we have 2n minus 2 equals 0, and so n would have to be +1. Right? Each copper is a +1, not the sum of the two. For this one, each oxygen is going to be a -2. We have 3 of those, so this is a total of -6 for the oxygen. Iron needs to balance that out. We have 2 of those, so -6 divided by 2, or 2 times n minus 6 equals 0. The n would have to be +3. For this one, for the nitric acid, we now have 3 different things that we need to work out, but we're going to do the same process as we were doing with 2. The oxygens are bound to the nitrogen, so they will all be -2. The hydrogen is not bound to a metal, so it will be +1. Then we got to work out what the nitrogen is. So we have 1 from the hydrogen plus n from the nitrogen plus 3 times -2 equals the overall charge, which is 0. Right? So that's 1 plus n minus 6 equals 0. So your n has to be +5. This one, lithium hydride, your hydrogen is bound to a metal, so this is where it will be a -1. And your lithium will be +1 to balance it out. Here, iron hydroxide, or iron 3 hydroxide, your hydrogen is bound to the oxygen, so it will be a +1. Your oxygen is not bound to another oxygen, so it will be a -2. And so your iron needs to balance out. So the oxidation number on your iron plus 3 times the number on oxygen, -2, plus 3 times the oxidation number of hydrogen, has to equal your overall charge, which is 0. So that's n minus 6 plus 3 has to equal 0. So n will be +3. Here, HPO4 2-, the oxygens are bound to the phosphorus, not the oxygen, so they will all be -2. Your hydrogen is not bound to a metal, so it will be +1. And now we need to figure out what our phosphorus is. So you have 4 times -2, or if we write it out similar to how we've been doing before, you have the 1 from the hydrogen plus the number on the phosphorus plus 4 times -2 equals the overall charge, which is -2. So that would be 1 plus n minus 8 equals -2. And so your phosphorus has to be +5 to make that work out. The way that you will figure out the oxidation number is by methodically going through and assigning the ones that we know. For those that you don't, you could draw out the Lewis dot structure, figure out which atom is more electronegative, and assign all the electrons in the bonds to the more electronegative atoms. We are going to be working through these three examples throughout the various videos to show step by step how you approach these processes. So the first step in redox reactions is assigning your oxidation numbers. So our chlorine molecule, right, this is in the elemental form. Chlorines are bound to themselves. So this will get a 0 charge, right, or a 0 oxidation number. Iodide is an element all by itself, an ion, and so it gets the same charge or the same oxidation number as the charge. Same with the chloride. Okay, and then for here we got our oxygen. It's bound to water, oxygen is bound to hydrogen, so that will be a -2. Each one of the hydrogens, you have 2 of them to balance out the charge. They each have to be +1. Oxygen here, each one will be -2. Right? We have 3 times -2 plus whatever the oxidation number on the iodine is equal to -1, and so iodine would have to be, or the iodine oxidation number would have to be +5 to get it to work out. For the second reaction, our oxygen is going to be -2. Our manganese has to balance out, so 2 or -2 times 4 is -8. When you add that to whatever the oxidation number is on the manganese, it has to come out to be -1, and so some number -8 equals -1. That number would have to be +7. Okay, for this, the oxygens are all going to be -2. There are 4 of them. The hydrogens will be +1 each. Okay, and then you have 2 carbons, so we'll have to work out what those are each going to be. So you have 2 times +1 plus 2 times whatever your number is going to be plus 4 times our -2 equals the overall charge, which is 0. So this ends up being 2 plus 2n minus 8 equals 0, which means that our 2n has to be equal to 6. So that means n would have to be +3. Okay, here our manganese is +2, the charge that's on it. Oxygen will be -2 each, and carbon will be, in order to balance that out, that's 2 times -2. The overall charge is 0, so carbon will have to be +4. Okay, our next one, chromium hydroxide. The hydrogens are going to be +1 each. The oxygen are going to be -2 each. There's an overall -4 charge, so the number that's on the chromium plus 4 times -2 for all of our oxygens plus 4 times +1 has to equal -1. So that's n minus 8 plus 4 equals -1. And so our number comes out to be +3. Here, our oxygens are -2. So n minus 2 equals our overall charge, -1. So the chlorine has to be +1. Okay, our chromium here, we got -2 for each oxygen. 4 times -2 is -8. Our chromium has to balance out with that -8 to give an overall -2, and so chromium will be +6 to get it to balance out. The last one, our chloride, because it's an ion, the oxidation number is the same as the charge. We will take this work on sequential videos and show how you can work out your oxidation reduction paths, figure out which one is your oxidizing agent and reducing agent, and pull out your half reactions.